Welcome to Digital Learning, Department of Collegiate Education. I am Dr. Vanaja V, Assistant Professor, Department of Mathematics. In this video, let us learn the reduction formula for integral tan to the power n of x dx and integral cos to the power n of x dx. This is the continuation part of integral calculus for first semester BSc Mathematics paper 1. The learning objectives are to derive the reduction formula for integral tan to the power n of x dx and integral cot to the power n of x dx, and also for definite integrals of the same functions. To apply these to evaluate given integrals. The learning outcomes are able to derive the reduction formula for integral tan to the power n of x dx and integral cot to the power n of x dx, and also for definite integrals of the same functions. Able to apply these to evaluate given integrals. Prerequisites: list of integral formulae, methods of integration, properties of definite integrals. So reduction formula for integral tan to the power n of x dx, where n is a positive integer. Let in equals to integral tan to the power n of x dx. Consider it as equation 1, where n is a positive integer. So in can be rewritten in this format. That is, in equals to integral tan to the power n minus 2 of x into tan square of x into dx. So then here we are already having the identity, that is secant square x minus tan square x is equal to 1. So tan square of x can be written as secant square x minus 1. So here integral of tan to the power n minus 2 of x into secant square of x minus 1 is equal to dx. Multiply these two things, that is tan to the power n minus 2 of x into secant square of x into dx minus tan to the power n minus 1 of x into 1 into dx can be taken as integral tan to the power n minus 2 of x into dx. See here, we cannot apply the integration by parts. Using the substitution method, we can integrate this particular term. To integrate this particular term, put tan x is equal to t. And the derivative of tan x, differentiate this function with respect to t. So derivative of tan x is secant square of x into dx, which is equal to t. Therefore, if you substitute that, tan as t means I can write t to the power n minus 2 and secant square x into dx is equal to dt. So under the integral. So we already are aware of integral of x to the power n into dx is nothing but x to the power n plus 1 whole divided by n plus 1. So applying the same formula, integral of t to the power n minus 2 into dt, which we can write in t to the power of n minus 2 plus 1, that is t to the power of n minus 1 whole divided by n minus 1, which is equal to t is nothing but tan. So tan to the power n minus 1 of x divided by n minus 1. So for this, integral of tan to the power n minus 1 of x into secant square of dx is easily integrated, and we can write it in this form, that is tan to the power n minus 1 of x divided by n minus 1 minus this term, that is integral of tan to the power n minus 2 of x into dx can be denoted as I into n minus 2, which is the reduction formula for integral of tan to the power n of x into dx. Once again we can memorize this one, that is in equals to integral of tan to the power n of x into dx can be written as tan to the power n minus 1 of x whole divided by n minus 1 minus of I n minus 2, which is the reduction formula for this. Next we are going to learn evaluation of integral 0 to pi by 4 tan to the power n of x into dx. Taking in equals to integral 0 to pi by 4 tan to the power n of x into dx. Let it be equation 3. So from the reduction formula, we are having in equals to tan to the power n minus 1 of x whole divided by n minus 1. So which is completely integrated. We can apply the limits from 0 to pi by 4. Minus, we left with the integral term, that is I n minus 2. So here we can apply the limits. If the upper limits, tan pi by 4 is nothing but 1 and tan 0 is 0. So here if I'll apply tan to the power n minus 1 of pi by 4 whole divided by n minus 1 minus tan to the power n minus 1 of 0 divided by n minus 1, tan 0 leads to 0. Then I left with the term tan to the power n minus 1 of pi by 4 is equal to 1. So I can write 1 divided by n minus 1 minus I n minus 2. So here again we have to get the value for I n minus 2. To get that value in this particular expression, we can change n by n minus 2. We'll get I n minus 4. To get that one, what we can do is changing n to n minus 2 successively in equation 4. So that is, if I change n to n minus 2 in equation 4, we get I n minus 2 equals to 1 divided by n minus 3 minus I n minus 4. To get I n minus 4, change in equation 4 I n by n minus 4. We get I n minus 4 equals to 1 divided by n minus 5 minus I n minus 6. So we can continuously do the successive terms of I n minus 6, I n minus 8, I n minus 10 like this way. At the end, we get two terms. One is I1 and another one is I0. That is the last one being I1 if n is odd and I0 if n is even. Where how to get the I1 value means I1 equals to integral 0 to pi by 4 tan of x dx. The integral of tan of x is nothing but log of secant x, and here the limits are given 0 to pi by 2. If I apply the thing, log of pi by 4 is nothing but log of root 2, because cos of pi by 4 is 1 by root 2. Secant of pi by 4 is root 2. So secant of pi by 4 is root 2, that is log root 2 minus log of secant 0 is, so 1, that is log 1 is always equal to 0. So we got the result I1 is equal to log of root 2 and I0 can be considered as 0 to pi by 4 into dx, that is equal to x, 0 to pi by 4 which is equal to pi by 4. So using 5 in 4 we get, that is in equals to integral 0 to pi by 4 tan of to the power n of x dx is equal to, which it is the alternate signs up to k, that is 1 divided by n minus 1 minus 1 divided by n minus 3 plus 1 divided by n minus 5 up to k. So if k means, if n is even, k leads the result as pi by 4. If n is odd, k gives the result as log of root 2. So similarly, we can understand the reduction formula for integral cot to the power n of x into dx, where n is a positive integer. So let in equals to integral cot to the power n of x dx, and where n is a positive integer, again cot to the power n of x dx can be written as cot to the power n minus 2 of x into cot square of x into dx. And using the identity of that is cosecant square x minus cot square x which is equal to 1. So we can write cot square x is equal to cosecant square x minus 1. So then again we can multiply these things, that is integral of cot to the power n minus 2 of x into cosecant square of x dx minus integral cot to the power n minus 2 of x into dx. So again we can, using the substitution method, we can integrate the first part of this, that is put cot x is equal to t. The derivative of cot x is minus cosecant square of x into dx. So therefore, integral of t to the power n minus 2 minus dt, which is equal to, after integration, it yields the result as minus t to the power n minus 1 whole divided by n minus 1. We have considered here t in terms of cot x, so the result gives like this way, minus cot to the power n minus 1 of x whole divided by n minus 1. The first part we can rewrite like this way, in equals to minus cot to the power n minus 1 of x whole divided by n minus 1 minus the integral of cot to the power n minus 2 of x into dx can be denoted as in minus 2, which is the reduction formula for integral cot to the power n of x into dx. Again we are having the another term, that is evaluation of integral pi by 4 to pi by 2 cot to the power n of x into dx. Taking in equals to integral pi by 4 to the power pi by 2 cot to the power n of x dx. So using the reduction formula, we are having in equals to minus cot to the power n minus 1 of x whole divided by n minus 1. The limits are given like this way, that is pi by 4 to pi by 2. Already this is integrated using the reduction formula, minus I n minus 2. After simplifying, that is cot of pi by 2, again it is 0, then minus of cot of pi by 4 is 1. So minus into minus we can get plus. After applying the limit, we can get the result as 1 divided by n minus 1 minus in minus 2. This formula ends on changing n to n minus 2 successively as we did before in integral of tan to the power n of x dx and sine terms and cos terms. We can get in equals to integrals pi by 4 to pi by 2 cot to the power n of x dx equals to 1 divided by n minus 1 minus 1 divided by n minus 3 plus 1 divided by n minus 5 up to some k we can write, or it is. The last one being I1 if n is odd and I0 if n is even, where what is the value of I1 means I1 equals to integral pi by 4 to pi by 2 cot of x dx, which can be taken, that is the integral of cot x is nothing but log of sin x. The limits varies from pi by 4 to pi by 2. Apply the limits, so we'll get, that is log of sine pi by 2 minus log of sine pi by 2, which leaves the term as 1 by 2 log 2. And I0 equals to integral pi by 4 to pi by 2 into dx, which is equal to x, that is pi by 4 to pi by 4. Again, after applying the upper limits minus lower limit, we'll get the term as pi by 4. So we can write in equals to integral pi by 4 to pi by 2 cot to the power n of x into dx equals to 1 divided by n minus 1 minus 1 divided by n minus 3 plus 1 divided by n minus 5 up to k. If n is odd, so then k becomes I1. So the last term we can use 1 by 2 log of 2. If n is even, then k becomes I0, and which gives the result as pi by 4. So based on these things, we can evaluate some of the problems. So evaluate the following. Integral tan to the power 5 of x into dx. We have in equals integral tan to the power n of x dx, which is equal to tan to the power n minus 1 of x whole divided by n minus 1 minus in minus 2. So in the place of n, just I can replace 5. I5 equals to integral tan to the power 5 of x into dx, which is equal to tan to the power 5 minus 1 is 4 of x divided by n minus 5 minus 1 is 4 minus I3, which is equal to, replace the first term as it is, minus I3 can be again in the place of the formula 1. I3 means in the place of n you can substitute 3. So tan to the power 3 minus 1 is 2x whole divided by 2 minus I1. So that is tan to the power 4 of x divided by 4 minus tan square of x divided by 2 minus, here I1 is given. I1 is integral tan of x. Integral tan of x dx is equal to log of secant x. That I can write minus log of secant x. Then I5 equals to tan to the power 4 of x divided by 4 minus tan to the power 2 of x divided by 2 minus 2 minus plus log of secant x. The second problem here is integral pi by 4 to pi by 2 cot to the power 7 of x into dx. We know that in equals to integral pi by 4 to pi by 2 cot to the power n of x into dx equals to 1 divided by n minus 1 minus 1 divided by n minus 3 plus 1 divided by n minus 5 minus up to k. Here we are having alternate signs, and in the denominator we are having n minus 1, n minus 3 and n minus 5 up to k. And here in this particular problem, the n equals to 7, that is given an odd number. Odd number means the last number k gives the result as I1, which is equal to 1 by 2 log 2 we can consider. So that is I7 is equal to integral pi by 4 to pi by 2 cot to the power 7 of x into dx equals to 1 divided by 7 minus 1 is 6 minus 1 divided by 7 minus 3 is 4 plus 1 divided by 7 minus 5 is 2 minus we are having I1, so I1 we can write this one half into log 2. After simplifying, that is considering the LCM and simplify, which is the result as 1 divided by 12 into 5 times 5 minus 6 times of log 2. Third problem, that is integral 0 to pi by 4 tan to the power 6x into dx. We know that in equals to integral 0 to pi by 4 tan to the power n of x dx equals to 1 divided by n minus 1 minus 1 divided by n minus 3 plus 1 divided by n minus 5 minus up to k. And here n is given as an even number, so k is and result as pi by 4. So therefore n is equal to 6. Therefore I6 is equal to 0 to pi by 4 tan to the power 6 of x dx equals to 1 divided by 5 minus 1 divided by 3 plus 1 minus I0, which is equal to 13 by 5 minus pi by 4. The next problem, it is related to cot function, that is d equals to integral cot to the power 8 of x into dx. We know that in equals to, that is integral cot to the power n of x into dx equals to minus cot to the power n minus 1 of x whole divided by n minus 1 minus in minus 2. So here n equals to 8, I8 equals to minus cot to the power 7x by 7 minus I6. Again replace this first term as it is minus of minus of cot to the power 6 means 5x divided by 5 minus I4. And again we can replace the thing here. Here we are having minus I6. I6 you can write, that is minus into minus it becomes plus, and minus into minus it becomes plus. It is the result minus cot to the power 7 of x by 7 plus cot to the power 5 of x by 5 plus I4. So I4 again I can replace as minus cot cube of x by 3 minus I2. Again simplify or multiply these things, we get the term as minus cot to the power 7x by 7 plus cot to the power 5 of x by 5, then minus cot to the power 3 of x by 3 minus of your I2 can be taken as minus cot of x by 1 minus I naught. Here I naught means any I naught, it is the result as 1. So we can rewrite the result as minus cot to the power 7 of x by 7 plus cot to the power 5 of x by 5 minus cot to the power 3 of x by 3 plus cot x plus x. Here we can just discuss one more problem, and afterwards we are having the references. Integral 0 to 1, that is x to the power 5 whole divided by x square plus 1 into dx. So let I equals to integral 0 to 1 x to the power 5 whole divided by x square plus 1 into dx. Put x equals to tan x. So then dx becomes secant square t into dt. So here x varies from 0 to 1. So therefore t varies from 0 to pi by 4. That is x is equal to tan t. If x is equal to 0, t becomes 0. If x is equal to 1, so t becomes pi by 4. T becomes pi by 4. So here put x is equal to tan t. So then here it varies. I is equal to 0 to pi by 4. That is tan to the power 5 of t divided by tan square t plus 1 secant square t into dt. So then which is equal to 0 to pi by 4 tan to the power 5 of t whole divided by secant square t. So after simplification it is 0 to pi by 4 tan to the power 5 of t into dt. So then we are having the formula, that is what is the thing here, in is equal to integral 0 to pi by 4 tan to the power n of x into dx is equal to 1 divided by n minus 1 minus of 1 divided by n minus 3 plus 1 divided by n minus 4 minus up to k. Here the term is given as n is equal to 5. So the last term is the term as log root 2. So then here I can write I5 is equal to 1 divided by 4 minus I3, that we can write 1 divided by 4 minus 1 divided by 2 minus I1, again that is 1 divided by 4 minus 1 divided by 2 plus log of secant. It varies from 0 to pi by 4, that is nothing but log 2 we can write. After simplification we get the result as half into log 2 minus 1 by 4. That is here we are having log of root 2 can be taken as log of 2 to the power half, that we can write half log 2 minus 1 by 4. So again these are the references to get the more information regarding this particular reduction formula. Thank you.